Okay, it tells us that if 1,200 square centimeters of material is available to make a box with a square base and an open top, what should we do? Draw a picture. Okay. So we have a box here. The base is square, and it does not have a lid on it. All right, so we need to kind of label these things. So we can pick a side and make it X, but if the base is square, then this side is also X. And then we need to label the height as something, so maybe Y. All right. I want to find the largest possible volume. How do you find volume of a box? Length times width times height. So we obviously have a problem because we have a Y in here. We can't have two variables. So we have to use the other information given. We have 1,200 square centimeters of material. What does that number represent? The surface area. Okay, surface area is just the area of each side added together. So we can find the area of each side. If we start with the bottom, what's the area of the bottom of this box? How do you find the area? X squared, length times width. X times X is X squared. It has an open top, so there's no top on it, so we don't have to add in that side. So let's talk about over here. If I looked at this side. Okay, the length of that is X, the height is Y, so that side would be XY. Okay, the front of the box. This is X, that's Y, so it would be XY. This side of the box would be XY. The back of the box would be XY. So we get 1,200 equals X squared plus 4XY. All right. So we need to take this and solve for one of the variables. Definitely going to be easiest to get the Y by itself. So if I subtract over my X squared, then we would have to divide by 4X. If I reduce these, 1,200 over 4X would reduce to 300 over X. X squared over 4X would reduce to X over 4. Have I lost anybody? What am I going to do with that? I've got to plug that in over here. So volume is X times X, or X squared, times Y, which we just got 300 over X, minus X over 4. You distribute, X squared times 300 over X would be 300X, minus X cubed over 4, or you might want to write that as 1/4 X cubed. We want to maximize this, so where do you go from here? Derivative. So I'm going to stop here. I'm going to leave you guys to finish it on your own. But we've got the setup. Does that make sense to everybody? So let's switch to our notes. I think we left off with this one. So a store has been selling 200 Blu-ray disc players a week at $350 each. A market survey indicates that for each $10 rebate offered to buyers, the number of units sold will increase by 20 a week. Find the demand function and the revenue function. How large of a rebate should the store offer to maximize its revenue? Okay, so we have a lot of stuff here. When I ask for the demand function, what am I asking you for? You might need to kind of look back yesterday. We talked about a lot of different pieces. What is demand? It's the price function. So we have to find out basically an equation for the price we should charge. Okay. So to get an equation, if we're trying to write the equation of a line, we need some points. Since I want an equation for price, that means the y needs to be my price. So my x would have to be the number of DVD players or Blu-ray players that we sell. Do we have any imported pairs in here? Right. When the number is 200, the price is $3.50. Okay, the second one, we have to figure out what happens. For each $10 rebate, if you offer a $10 rebate, what's happening to your price? It's going down. So the price is now $3.40. The number of units sold will increase by 20. So how many would we sell? 220. So now I can write the equation of the line. We need a point in the slope. So slope y sub 2 minus y sub 1 for x sub 2 minus x sub 1. Maybe negative 10 over 20 or negative 1. Negative 1/2. So that is not. Okay, where do we go from here? Okay, take one of our points in our slope and plug in y equals mx plus b. So if I just use the first one at my slope, my y is 350 equals m and 1/2 times x, which was 200. So our price function, or the demand function, that's your lowercase p, is negative 1/2 x plus 450. Then I asked you for revenue. What is revenue? Revenue is the amount of money you're bringing in. So it's the number you sell times the price you charge. So if I distribute an x through there, we get negative 1/2 x squared plus 450x for the revenue. All right, now what am I trying to do? What is the problem asking me to do? Maximize revenue. How do you maximize something? You do the derivative and set it equal to 0. So the derivative of my revenue would be negative x to the first plus 450. Let that equal to 0 and we get x to be 450. All right. The question was, how large of a rebate do we need to maximize the revenue? So this tells me that my revenue is maximized when X, or the number of DVD players, is 450. So we need to find the price then. So what would we do? Plug 450 into your price equation. So the price of 450 DVD players, or Blu-ray players. And we get 225. 225 plus 450. So that's the price, but the question is, what's our rebate? So how would we find the rebate? Right. Your beginning price minus your ending price is basically telling you how much you dropped your price. So we had to offer a $125 rebate to maximize the amount of money we will bring in. Questions there? So these revenue, price, demand problems, the math isn't so hard, but you have to think a lot. Am I talking about revenue or cost or price? So we have to pay close attention to what we're doing here. All right, let's look at this example. It's kind of related to that number 15 that we did, or that we talked about from your homework last night. So this one tells me we need to design a cylindrical can. What does that mean? What's a cylindrical can? Yeah, like a soup can. With radius R and height H. So height, radius. The top and bottom must be made of copper, which will cost 2 cents per square inch. The curved side is to be made of aluminum, which will cost 1 cent per square inch. Find the dimensions to maximize the volume of the can if the total cost is to be 300 pi cents. Alright, so volume of a can. Volume is like area of the base times the height. Okay, so the base is a circle, so area of a circle is pi r squared times the height. We want to maximize this, so that's what we need to do the derivative of, but we can't until we get rid of one of the variables. So we have to go back and look at what other information we have. And I give you information about the cost. Okay, my total cost is 300 pi. We have to pay for the top and bottom 2 cents per square inch. So square inch, that tells me we're talking about surface area. What's the area of the top? Pi r squared. And if I'm finding how much I have to pay for that, you have to take your area times the cost, which is 2 cents. Now you'll notice this 300 pi is in cents, so I only have to multiply this by 2, not 0.02, because everything is in cents. Does that make sense? That sense make sense to you? Okay, let's talk about the bottom. So area of the bottom is pi r squared, and how much do we have to pay for the bottom? 2 cents. All right. Now the side. So think about if you took the label off your soup can. Okay, so you unpeel it and unroll it. What shape is it? Rectangle, right? So area of a rectangle is just length times width. So this would have a width of h. The length of that soup can, or the length of that label, is the same as the total distance around the soup can, right? What's the name for distance around a circle? Circumference. How do you find circumference? 2 pi r. So that gives me the area of that piece, and how much do we have to pay for it? Only 1 cent, so we're just taking that 1 times 1. Alright, so 300 pi. 2 pi r squared plus 2 pi r squared is 4 pi r squared. 1 times h times 2 pi r is plus 2 pi r h. What variable would it be easiest to solve for? H, probably. So we can subtract over divide by 2 pi r. I'll reduce these. 300 pi over 2 pi r will be 150 over r minus 4 pi r squared over 2 pi r. It's just 2r. Okay. So all of this work was to figure out what h is. Now we can plug that into our volume. We said the volume of this was pi r squared h, but I'm going to replace my h with 150 divided by r minus 2r. So if we distribute pi r squared times 150 over 150 pi r minus pi r squared times 2r, 2 pi r cubed. Right, then what do we need to do? Pi is just like a coefficient, so the 150 pi is just my coefficient. Derivative of r is 1, so we get 150 pi minus 6 pi r squared. We know this should equal 0. Divided by 6 pi. Pi's dropped 150 over 6 gives me 25. Square root. With that, you would do a plus and a minus. Can you have a radius of a negative length? No. So it has to be a positive pi. So my question was for the dimensions of the can. In other words, we need the radius and the height. So the radius is 5 inches and the height is, so to find that we look back, remember h was 150 over r minus 2r. So that's 30 minus 10 or 20. So I'm asking you to find the point on the parabola, y squared equals 2x, that is closest to the point 1/4. How do we measure how close things are? What's the word for how far apart things are? Distance. Do we have a distance formula? Probably. We do. If you remember way back when, college algebra, we did it. The distance between 2 points is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay. We have 1 point. We need a set point. Would it be easier to solve this for x or for y? I would rather get x by itself. If I get y by itself, I have to add a square root in there. And I really don't want to do that. So if I get x by itself, x would just be, if I divide over the 2, 1/2 y squared, or y squared over 2. So that means my second point, x is 1/2 y squared, and y is just the variable y. So if we set up our distance formula, the square root of x sub 2, so 1/2 y squared, minus x sub 1 is 1 squared, plus y sub 2 is y, minus y sub 1 is 4. This is pretty ugly because of the square root. If I want to make d as small as possible, that's really the same thing as making d squared as small as possible. So if I want this to be tiny, we could just find when d squared is as small as possible. In other words, we can minimize this without the square root. And that just makes our math easier without changing the answer. Now if I want to minimize something, we need a derivative. But what should well, we can do the derivative, or we can multiply this stuff out first. It's not going to make a difference. You guys just want to do the derivative? So if I do the derivative of this, so I'm doing basically the derivative of d squared, we'd have to do the chain. So the 2 comes down, inside stays the same, subtract 1 from the power, times the derivative of the inside, derivative of 1/2 y squared, which is by. Plus, this one, 2 comes down, inside stays the same, subtract 1 from the power, derivative of the inside is just 1. So if I distribute a 2 and a y through here, I get y cubed minus 2y. Distribute the 2 here, that's 2y minus 8. So we get y cubed minus 8. And what do I want that to equal? Let's see. So y cubed is 8, which means cube root of 8 is 2. We need x, but we said x was 1/2 y squared. So 1/2 times 2 squared, 1/2 times 4 is 2. So the point is 2, 2. So, yesterday I gave you guys 3, 7, and 15. So hopefully you might have had some questions on 15, but hopefully you can finish that up now. Today I want to add in 5, 33, 59, and 61. So, adding in 4 more products. This will be due, let's see, Friday, high school, Monday, so it'll be due Tuesday. But I am going to give you something else tomorrow as well. So tomorrow is going to be a work day for us. I would not just come in having done none of these, plus you have time right now, you can get some done. But I'm also, I think instead of giving you the rest of the book problems, I'm probably going to make a worksheet that I'm going to give you tomorrow as well. So that'll give us some time to practice.